In this video, we will continue to practice finding the derivative of inverse trig functions like this one. However, right now we will go a step further and find the equation of the tangent line at a point. Whenever they ask me to find the equation of a line, I like to use point-slope form because it reminds me that all I have to do is find a point and the slope. In this case, part of the work has been done for us already because they gave us a point, the point of tangency. So all we have to do now is find the slope. If you were looking for the slope of a function at a point, you need to find the derivative. Here is a fact that you just have to memorize. The derivative of arccosine is equal to -1 over the square root of 1 minus x squared. Also, please understand that you will sometimes see arccosine written as inverse cosine with the -1 superscript. These are two ways of writing the same exact thing. So anyway, if I want to find the derivative, y prime, I will leave the 1/2 constant alone in the front, and now I'm taking the derivative of arccosine x, which I just showed you is this expression. So I think I'll just actually stretch this out, and I will turn this one into a -1 because of the rule, and I will put the square root right here. So I have 1 minus x squared. So that's it for the derivative. Now I want to evaluate the derivative at the x value of -2 over 2, because that is the x value of the point of tangency. So this will give me the slope of this function at this particular point. So I am substituting -2 over 2 in for x squared, and this is what I get. If you square something that's negative, you're going to get a positive. So this negative will go away. Squaring the numerator and the denominator, I will get a regular 2 over 4. So now I have this. 2 over 4 is really 1/2, and 1 minus 1/2 is 1/2. So now I have this. If you take the square root of a fraction, you simply take the square root of the, you take the square root of the numerator and the denominator separately. So this is going to be 1 over the square root of 2 right here. But, so this will really just be 2 over radical 2. So now I have -1 over 2 over radical 2. When you put 1 over something, you're just taking the reciprocal. So this really means the reciprocal, which would be radical 2 over 2, but the negative is still there. So ultimately, the slope that we were looking for, the slope at an x value of -radical 2 over 2, is -radical 2 over 2. What a coincidence. Now that we have a point and the slope, we can go ahead and write the equation of the tangent line. It'll be y minus the y value, which is 3 pi over 8, is equal to the slope, -radical 2 over 2, times x minus the x value. Since this is minus a negative, I'm going to go ahead and put a plus instead, plus radical 2 over 2. So that's it for number 60. The directions are the same for problem number 64. Here is the fact that you must memorize. The derivative of arcsine is +1 over the square root of 1 minus x squared. The derivative of arcsine and arccosine are the same, except for the derivative of arcsine is positive, while the derivative of arccosine is negative. Again, we are given a point, the point of tangency, so all we need is the slope in order to write the equation of the tangent line. In order to find the slope, we will have to find the derivative, which will give us the slope of this curve at any point, including this one. So this is a product, so we will have to use the product rule. I'm going to take the derivative of the first factor, which is just going to be 3, and then I'm going to multiply by the second factor unchanged. So I'm going to leave arcsine x alone. And then I'm going to go through it again. The second time through, I'm going to leave the first factor alone. And I will take the derivative of the second factor. And I believe I just mentioned that that is 1 over the square root of 1 minus x squared. Because the x value of the point of tangency is 1/2, I need to evaluate the derivative at an x value of 1/2. So I'm going to substitute 1/2 for every x value I see. So we will have arcsine of 1/2 plus 3 times 1/2 times 1 over the square root of 1 minus 1/2 squared. When you see arcsine of 1/2, you should be thinking to yourself, the sine of what angle is equal to 1/2? And the answer to that question will tell you the reference angle, which is pi over 6. The sine of pi over 6 is equal to 1/2. So here is our reference angle of pi over 6. However, the sine function is positive in the first and second quadrant. We need a positive 1/2. And this position also has a reference angle of pi over 6. So what about this? We don't have to worry about that because arcsine is only defined between negative pi over 2 and positive pi over 2. So the answer will be pi over 6. By the way, here are the restrictions on the other inverse trig functions. Pause the video and take notes if you need to. So we have 3 times pi over 6 plus, well, this will just be 3 over 2. I think I'll just go ahead and put it like that. And in fact, I think I will incorporate it with the whole square root situation. So I have the square root here in the denominator. 1 minus, if I square this, it will be 1 over 4. So we have this now. 3 times pi over 6 reduces down to pi over 2. And I still have my 3 and my 2. 1 minus 1/4 is 3/4. If I take the square root of the numerator and the denominator, this will be the square root of 3 over 2. And on the next step, these 2's will cancel each other out. So we will just have 3 over radical 3. If this was a free response question, you could just leave the slope like this. But what if this were a multiple choice question? They would probably rationalize the denominator. So I want to just show you that real quick. If I multiply by radical 3 over 3, then I'm going to have the following. Pi over 2 plus, and this would be 3 radical 3 over 3. And then the 3's cancel each other out. I don't feel like recopying the entire thing, so I'm just going to put radical 3. So this is the slope. Now that we have a point and the slope, we can write the equation of the tangent line. It goes like this: y minus the y value, so y minus pi over 4, is equal to the slope. So let's be careful, because this is a binomial, we are going to have to write the slope in parentheses for it to be algebraically correct. So there's our slope, and then we multiply that times x minus the x value of the point, so x minus 1/2. And again, these parentheses are absolutely necessary. Switching gears a little for number 70, we need to find any relative extrema of this function. If there are any relative extrema, they will occur at the critical numbers, which come from the derivative. So we have to find the derivative. The derivative of arcsine x is 1 over the square root of 1 minus x squared. The derivative of 2x is just 2. So, time to find the critical numbers. The critical numbers are the values of x that cause f prime to either equal 0 or be undefined. Let's start by setting f prime equal to 0. So we have this. Adding 2 to both sides, we have 1 over the square root of 1 minus x squared is equal to 2. Taking the reciprocal of both sides, we have the square root of 1 minus x squared is equal to 1/2. Squaring both sides, we have 1 minus x squared is equal to 1/4. Subtracting 1 from both sides gives us negative x squared equals negative 3/4. And dividing both sides by negative 1 gives us x squared is equal to 3/4. Taking the square root of both sides, we get x is equal to plus or minus the square root of 3 over 2. So we have 2 critical numbers so far. How about the values that will cause f prime to be undefined? That will happen if the denominator here is equal to 0. And more specifically, we can just focus on what's inside the radical. So for this denominator to be 0, 1 minus x squared would have to equal 0. Adding x squared to both sides, we get 1 is equal to x squared. Taking the square root of both sides, we get x is equal to plus or minus 1. So we have another 2 critical numbers. Let's put these 4 numbers on a number line and make a sign chart. As we do so, keep in mind that radical 3 over 2 is approximately 0.9. Make sure you label your sign chart as f prime. Let's use some test values to find out whether the derivative is positive or negative in each of these intervals. Actually, I want to focus on the denominator here for a moment, the square root of 1 minus x squared. If we pick a value in this first interval, so imagine a number that is less than negative 1. So for example, negative 2. Then we would have the square root of 1 minus negative 2 squared, and that would give us the square root of 1 minus 4. This is going to give us a negative number under the radical. So this would not be a real number. So we can forget about this interval because we don't have real numbers. And the same thing would happen if we picked a value in this interval, because it doesn't matter. If this were positive 2, we would get the exact same thing. No real numbers. So now we are down to just 3 intervals that we need to test out. Let's do the easy one first. This middle interval has 0 in it. So if we use an x value of 0, then this x squared would just be gone, and we would just have 1 over the square root of 1 minus 2. But this would just be 1, and 1 minus 2 would be negative 1. And all we really care about is this is a negative value. Next, let's try to find a test value between radical 3 over 2 and 1. Unfortunately, this turns out to be very tedious. I've got radical 3 over 2 and I've got 1. I'm trying to find a value between these, but they are very close together, so it's a little bit tricky. I'm going to start by thinking of 1 as 2 over 2, so I can compare these more easily. Now, I can also think of the 2 as the square root of 4. So I need a number between these two values. But you can really focus on the numerators, since now the denominators are the same. I need a value, a numerator between radical 3 and radical 4. So the first thing that pops into my head is 3.5. Obviously, I don't really want a decimal, so here's the journey I'm going to go on. 3.5 is the same thing as 7 over 2. So this magical value that is between radical 3 over 2 and 1 is the square root of 7 over 2 over 2. I would love to be able to simplify, so I'm going to multiply by 2 over 2 just so I can get a square root in the denominator. So now I have the square root of 14 over 2 because I took the square root of 4 and I got 2. When I do this division, this 2 is going to end up in the denominator with the other 2. So that's going to be the square root of 14 over 4. Ta-da! So I did all of this just to find the test value that is between radical 3 over 2 and 1. So I'm going to use a test value of radical 14 over 4. So now I'm going to plug it in to the derivative and see if it's positive or negative. Squaring the radical makes the radical go away, so I just have 14. And then squaring the 4 gives me 16. But I can write the number 1 as 16 over 16. So that's going to give me 16 minus 14 is 2. So now I have the square root of 2 over 16. But this simplifies down to 1/8. Taking the square root of each of these, I have 1 over 1 over the square root of 8. Multiplying by the reciprocal here, I'm going to get the square root of 8 minus 2. And the square root of 8 is 2 radical 2, which is definitely bigger than 2. So when I subtract, I will definitely get a positive number. Phew! I told you that was tedious. I'm not going to go through all that again for this last interval. It's the same exact thing. So it's going to also turn out to be positive. We know that if the derivative is positive, the original function is increasing. If the derivative is negative, the original function is decreasing. So that tells us that we will have a relative max at this x value and a relative min at this x value. Okay, it's time to write our answer and justification. When we write that justification, we will base it on the first derivative, not the original function. So we won't talk about f of x increasing and decreasing in certain places. Instead, we will say that we have a relative max because the first derivative goes from positive to negative, and a relative min because it goes from negative to positive. So we would say f of x has a relative max at x equals negative radical 3 over 2 because f prime goes from positive to negative. F of x has a relative min at x equals positive radical 3 over 2 because f prime goes from negative to positive. Last one. Use implicit differentiation to find an equation of the tangent line to the graph of the equation at the given point. So let's differentiate both sides of the equation with respect to x. The derivative of arcsine is 1 over the square root of 1 minus x squared. Similarly, the derivative of arcsine y is 1 over the square root of 1 minus y squared. However, because these variables do not match, I have to use the chain rule and multiply by the derivative of y, which is dy dx. And then the derivative of a constant is 0. We just need to get dy dx by itself, so I'm going to subtract 1 over the square root of 1 minus x squared from both sides. I'm moving this over there. So now I have this. On my next move, I'm going to multiply both sides by the square root of 1 minus y squared. That way these will cancel out and I will have dy dx all by itself. So we have dy dx. But remember, the directions are to find the equation of the tangent line. And in order to do that, we are going to need a point, which we have, and the slope at this point. And that's what the derivative is all about. This equation will give us the slope at this point. All we have to do is substitute x and y into this equation. This actually works out very nicely because the x value and the y value are the same number. When you plug those in for x and y, it makes the numerator and denominator identical. So this is actually just -1. So this is the slope. Now that we have a point and the slope, we can easily write an equation of the tangent line. It goes y minus the y value, which is radical 2 over 2, is equal to the slope, which I will just put a negative sign, times x minus the x value of radical 2 over 2. So that's it. There's your final answer.